my name is Jack DeGrave. I'm a business development scientist with FormFactor, and today I'll be talking a little bit about our position in the quantum marketplace, specifically around cryogenic test and measurement. So a quick introduction to FormFactor. FormFactor is a publicly traded company. We've been so since about 1993. We're about 2,200 people with worldwide offices. And we do cryogenic test and measurement, and we do systems and probe cards and everything else associated with test and measurement at cryogenic temperatures. Right now, we span the temperature range from 300 Kelvin down to about 50 millikelvin. So today, I'll be focusing on our new test service business. So we serve a variety of different qubit regimes. So we do superconducting devices at 4K and 50 millikelvin, CMOS or control chips, as well as components at 4 Kelvin, 77 Kelvin and below, and then also photonic devices. So one of the things we've noticed with the quantum marketplace is that really cryogenic test equipment is something that's very expensive. It comes with a high capital cost and also really long lead times. And this has really limited the access for quantum developers to sub 4 Kelvin and 2 millikelvin systems, which has resulted in slowed development cycles and really the inability of certain component suppliers to qualify their devices at those operating temperatures. So our solution to this is to provide test as a service. So this is our new cryogenic test and measurement as a service platform. Basically, you can engage with us immediately. We have systems available, and it provides immediate access to quantum computing developers. And developers are using this service to reduce R&D risk, learn design for tests. You get access to probe cards and different probe head technology to interface with your DUT. And we're really trying to eliminate that high capital cost barrier to working with cryogenic equipment. And a lot of people are also using this to prepare to scale, trying to understand what you can do at the wafer level, what are the types of measurements and data that you can get to inform your program and improve your fabrication process. So right now we have two different systems available. So the first one is a 50 millikelvin ADR cryostat. This is for chip and component testing. It can be paired with a probe socket, so we can easily interface with the device. It's customized to your particular pad layout. Then we also have our wafer testing system. So this is right now for 200 millimeter wafers. It's magnetically shielded, so it's well suited to measuring superconducting qubits. And as part of this kind of initial launch of the program, we're offering 3 free test days on the wafer prober associated with a probing package. So what does test service engagement look like? Basically, what happens is when you engage with us, you're going to be working with our application specialists and measurement experts. So it starts with your idea. Maybe you have an idea of something you want to measure, whether it's at millikelvin or 4 Kelvin to inform a fabrication process. Then once you're working with our application experts, we're going to finalize a test plan and define how we're going to interface with that device. So a variety of probing solutions are available, whether it's full-scale wafer probe cards or probe sockets for chip level testing. Once we have that plan in place, we're set up and ready to go. So we'll test and measure chips and wafers. We have a variety of test equipment available to our users, which includes things like VNAs, basic source measurement equipment. Then once we have a result, we'll analyze and discuss the data with you and feed that back into your program, and we can iterate on the test procedure. So when it comes to the wafer prober, we're seeing a variety of use cases. So a lot of this is statistical process control for scaling. So measuring on wafer allows you to get that inline measurement and acquire data so that you can inform your fabrication process and iterate on that. We've done niobium resonators doing S11 and S21 measurements. JJ resistance, we have a paper out with MIT on the archive right now, so you can take a look at the link down below. And then some people are also interested in informing how you might get room temperature diagnostics on qubits and inform their low temperature performance. And this is really the idea of building machine learning models. And in order to do that, you need very high volumes of data. So the wafer prober is very well set up to do this type of thing. When it comes to the 50 millikelvin test service, qubit and resonator pre-characterization is the main goal. We have a solution brochure up on the website if you want to read more about that. It's also being used for process control and materials development. Vendors can use this system for component qualification. So you can install a component, see how it performs at millikelvin temperatures, and then provide some sort of performance validation to your customers. So with that being said, we're looking for quantum developers and component suppliers to engage with this new cryogenic test service. So please bring your idea to us and we're ready to discuss. Thank you.
Great, thanks, Jack. So in terms of your test service and your 3 days of free test, what's the typical lead time from start to finish for one of these cryogenic test services?
Yeah, so the lead time really comes down to the probing solution, right? So these systems we currently have available and we can engage right away. And it's really a question of if it's at the chip scale, do we need a custom probe head or a custom device interface there? And some things, we have in stock. So some things are, maybe 2 to 3 weeks out. And then, others, like a full scale wafer probe card might be a little bit longer than that. So again, the system's immediately available and it, lead time is really dependent upon that probing solution or the device interface solution.
Great. Thanks, Jack.